I'll take over from what Professor Hunter said. We are exploring as a joint collaboration how a behavioral model can be exploited to frame the future EV demand. By EV, I mean automated vehicles, obviously. This is framed in a wider, let's say, research project that aims to integrate two different models for the same city to frame both the demand related to automated vehicles and the supply, because automated vehicles may be used by more people and they may have a very disruptive effect on the road network, which in turn would affect the demand. If the congestion worsens a lot, no one will use automated vehicles, regardless of the comfort on board, regardless of the cost, of the distance, and so on. The first piece of this wider integration, which is what I will focus on today, is an agent-based model named SimMobility that is able to frame, as I was saying, the result of the behavioral model, so the number of tours, the destination, the distance, the modal share, and so on. While on the right, there is the other part, which is Aimsun, which is going to be used for the supply side and to simulate a fleet of automated vehicles. An agent-based model requires a very large database. And this is where the developed database and the synthetic population part of the presentation becomes topical, because this data set does not exist for privacy concern. You need details about the income, the household structure, the workplaces, the education, and so on, up to the individual level. So the first thing we had to do was to develop this synthetic data set, which is open access, completely anonymized, so can be exploited also by other researchers. It includes 400,000 individuals and all the households. It was developed also in a joint with, thanks to the help of Professor Antov that shared a survey that we could upscale. It was 4,000 individuals and we upscaled it to 400,000. These are just some results to show that in the end, this phase was quite successful. You can see the share of the residents across Tallinn on top in the synthetic population dataset, and on the bottom left, you can see from the census what is the distribution. On the right, we can see that the match is almost perfect. The same can be said about income level, even though on the right from the synthetic data set, we kept it qualitative to keep it anonymized. So it is very high income, medium income, and low income. But the distribution, again, has been framed somehow correctly. We focused also a lot on the workplaces and education anchor points, which are, again, not public at the individual level, but are very important for a behavioral model. Also in this case, we finished the activities and we got satisfactory distributions. On the right, you can see how the total per each district matches, and on the left, it is framed how the origins and distributions do match. If we take the example of the Lasnamäe district, we can see that most of the people residing there either work in said district or work in the central district of Kesklin. So it's what one could expect. This data set is pretty disaggregated. We are talking about a 500 times 500 meters grid, which also frames land use patterns other than just the totals. This is an example of the resident from Nome that work near the harbor. And we can see that in the more residential areas, we have a fewer concentration, while in the areas that are dedicated to the harbor or in the southern part, which is filled with business services and offices, the concentration is higher. So this is also an OD matrix that we validated against an existing study. The distribution, again, it was quite satisfactory, and I cannot stress enough that the synthetic population right now is public. So it's also pretty easy to exploit, because in the end, it's a very big CSV file with a legend and all the entries related. And it is on a GitHub folder. It has been described in a publication, so there is the whole process detailed if someone wants to exploit it. But now let's focus a little bit more on the joint work and how can we exploit behavioral models with a similar data set. As Professor Antov said, and I am collaborating with Andres on this, there are the results of a survey from the Rae area. Also, there will be a trial there, so we will have also some feedback after actually the exploitation of automated vehicles, so it will be validated in the, let's say, with real data. So we will have this willingness to use the automated vehicles for various kinds of trips, for various distances, for various prices. And we will be able to see, again, how people would use these vehicles and to frame for which kind of trips these vehicles are actually the most useful. But this is for the Rae area. So it is on a, let's say, smaller number of people. What is one of the research direction we could follow up then is to upscale this, let's say, propensity of the Rae population towards automated vehicles to the whole Tallinn area, because with those results as they are, we can, through a regression model, probably we can frame what is the typical persona that would use an automated vehicle. Is it a worker? Is it a working age person? I mean, is it a retired person? Is it students? And so on. So that will be the first result. How from the Rae area the connection is improved. But then we could upscale it with the synthetic population to also see what is the market base actually for automated vehicles, what is the business case that could be defined, and then upscale the results from the Rae area to the whole Tallinn population. This will be useful especially in defining the business case and the feasibility at a market level. As I was saying, the agent-based model that we're using is a behavioral model. It is based on nested logits, and so typical transport behavioral model. But what is possible to frame through it is the exact number of tours, the mode and destinations, and the time of the day. Those are the main steps for each individual, again, which is very, very detailed. And if we do this by upscaling the behavioral parameters that we get from the Rae area to the wider area, we could be able to frame the total number of trips that Tallinn would actually generate with automated vehicles. This is one of the applications that is envisioned both with this collaboration, but yeah, focusing on the Rae area. While if we shift again the focus on Tallinn, the building of this agent-based model and the building of a transport model in Aimson will allow us to carry out simulation that covers, let's say, all the sides of the transportation problem. This is something that cannot be done right now at the state of the art, and especially cannot be done with automated vehicles. It means that we will be able to carry out simulation that frame the overall demand in a realistic way, because the agent-based model is something that is already in literature, has already been validated, and can give very detailed results. But then we could validate this demand with the actual performance of the transport network. And the final results will be finally a fleet of automated vehicles that absorbs a defined demand and then reproduces the supply performance in a way that the demand doesn't actually change. Is that so? You can actually build a case on that, because right now it's not possible, obviously, to have a trial at a city level because automated vehicles are prototypes, very limited in numbers, and there is a specific legislation and regulation and some boundaries. But at the simulation level, it will be possible to be achieved. Again, I'm showing some results from the two models. it is important to highlight the tour generations. That's what we will, with the results from the tour generation, one could actually forecast the earnings for a certain fleet. What are the revenues, the total revenues, because you have the total of number of tours, and you also have the modal share and the potential heavy demand that is absorbed, that will be based ideally on the Rae data. And since the Rae is so close to Tallinn, it is hard to imagine that there is a socio-demographical difference there that would make these results not as solid. This is just an example, not a very nice one, but it's the best way to show the detail. We have, for example, person number 4 that does just one trip through the day with, let's say, another motivation. There is a person 35 that goes to work and then comes back to home. We have the location, we have the mode, we have if the stop is the primary reason she or he left the house, the times of arrival and departure, and the trip chain through the day. Again, this is all modeled, so it's all anonymized, but it's also based on a behavioral model, so it's realistic. It has been calibrated against the overall number of trips generated in Tallinn and the recorded modal share. Other applications very quickly with what we have so far is that, for example, with the synthetic population database, it is possible to assess future scenario in a very detailed way, because again, it is very anonymized and it's very detailed. So it is possible, for example, to test different remote and hybrid working patterns, which is very, very actual right now. And it is possible to assess the future scenario with different trends, just to, let's say, understand the outcomes and their effect, not only on mobility, but I'm also thinking about the real estate markets, because you have different zones, different patterns, maybe tied to the income level, maybe tied to the gender age distributions, and so on. Accessibility studies are also possible in that sense. This could also be carried out with automated vehicles, meaning that, for example, in the Rae area, an accessibility study is very much in the things. We can carry it out because we have the output from the survey. We will model the typical personas that will benefit from the automated vehicles fleet. And there was another one. Well, obviously the synthetic data set is an alternative source of data for any kind of model building that could be there. But that was my presentation. I don't know if Andres wants to add something to what I mentioned, or otherwise the question we said to the end. Thank you so much for your attention.
Yeah, Andres, feel free to say something if you want.
I can say 2 things. What is very positive. I see that the presentation of Dago Antov is very informative, and he has lot of novelty for one scientific paper already now, Dago Antov. And Serio has also lot of information already in this stage for very good cooperation paper, second cooperation paper already. But we are working with Aalto Group and mostly with Serio and Dago Antov to make some kind of joint paper. And we are in the phase of agreeing the concepts of models, how our knowledge can be joined with the knowledge and ideas of Serio, and to make some kind of mathematical model that combines, hybrid model that combines the both concepts. So because we are in the very beginning stage, I would not like to confuse the situation in this very early stage, because we have already very good information from Dago and from Serio today, what is very, very well explained. So I will not present my ideas. It is on the base of bookkeeping, how we divide the trips from one zone of to districts of Tallinn. Must we divide the population to the groups? My opinion was that the number of groups of population must be minimized, and it can be minimized to 2 groups. In the morning rush hour, those who stay at home and those who move, either to schools or other to workplaces. Serio is trying to build such kind of model what has more groups of population. So I think both ideas can be somehow joined.